Okay, so I want to start working on indexed rendering. Here's the basic idea. Let's say, or the classic idea is if we have a rectangle that we want to draw, in traditional rendering we just draw the three vertices, 0, 1, 2, but then how do we draw the other triangle? Well, we would make copies of those same vertices at the same positions and with exactly the same attributes. So we then have, I don't know, 3, 4, 5. So as you can see, some of these vertices get doubled up on, which is pretty pointless. So what we can do instead is we'll have a set of vertices which contain a whole bunch of data, and then we'll have a set of indices which refer to those. So I'll call this point index number 0, and that refers to the first position of the vertex buffer. And then we'll have index number 1 and index number 2, and those will be referring to these things in the vertex buffer. And then I'll have index number 3. Then I need to state which order I'm going to draw these, fetch these points, and I'll do it like this. I'll go 0, 1, 2, and then 2, 3, 0. Doesn't seem like a massive saving, but in the long term, as we add more and more vertices for larger models, we save on space. Now, that reconstruction does get done on the GPU, but it is more efficient than grabbing a whole chunk of wasted data. And there is another benefit to that, and that is later on when we look at ray tracing acceleration structures really like index drawing. So this is all well and good. What I would do is if I went to draw this, I would say something like, okay, so we'll say start index is equal to 0, index count is equal to 6. That's how we would draw that. But then things get a little more complicated, because what I want to do is not just have a whole bunch of different index buffers, but have a big lump where I grab everything all together. So let me go to a more complicated example. Let's say that we have a rectangle and a triangle, and each of them have their own index and vertex lists locally. So I'll call this index 0, 1, 2, 3. It really doesn't matter which order I draw this. And here we have locally index 0, 1, 2. Okay, so I'll consume the rectangle first. So I'll say, okay, the start index is 0. Index count is 4, because there are 4 things. Well, see, this is where things get a little more complicated, because let me draw this up. So I consume this data, and my indices will be going 0, 1, 2, 0, 1, 2, and then 2, 3, 0. So although we do get 4 indices when we go to draw this, we've really got 6. And I messed that up because that's the data that we would have available to us when we go to consume this. Okay, but let's look at the next triangle. So what I'm going to do is I'm going to take all these positions and these indices and append them onto the list that I've got right now. So what I would do is I would look and I would say, okay, how many indices have already been defined? Well, it's easy enough to calculate that we have had 4 indices defined. So if we go, vertices I mean. If we go look at vertices, we'll have some data for vertex 0, 1, 2, and 3. So we have 4 vertices so far, and we can check the size, the number of those, and I'll just do like a little local relabel. So I'll say, okay, now this is index 4, this is index 5, and this is index 6. But then, what is the start index? It's tempting to say that the start index is 4, because that's the first thing that I've got here. But if I look at my indices, because this is what I use to draw, when I say draw starting at index 0, drawing 6 things, it's starting from position 0, reading the first 6 things within my index buffer. Okay, so start index. Well, if we go 0, 1, 2, 3, 4, we're going to start actually drawing some of the data which was defined in the rectangle before, which is really not good and really confusing and hard to debug. So what we do instead is we take the number of indices which have been defined so far, and that's the start index for the next shape. So again, I'll pop this data on. So we have 4, 5, and 6. And then index count, it's clear to see from the local index data, which has been defined, that we have 3 indices. This is a very simple shape. The number of indices is the same as the number of shapes. So again, if I were to draw this, I would start at position 6 within my index buffer. So I go 0, 1, 2, 3, 4, 5, 6. So I'm completely free of the previous shape. And then I take the next 3 indices. And of course, well, now the first one is going thing 4. So 0, 1, 2, 3, 4. That's the new triangle position. And that's sort of how we do it. So this has been an overview of what what indexed rendering is, and how we might want to take a number of shapes and compress them together into larger lumps of data. Okay, so this has actually been so useful. I'm actually going to clip this and I'll put this in my fundamentals playlist, but I've also got a Vulkan thing to do, so I'll see you in one of those. All right, so let's put this into practice. This is going to be pretty satisfying. It's very nice. Okay, so we'll just go to the engine and, well, the usual drama. Then I'll head down to the create assets function. There we go. Okay, so what I want to do is I want to implement indexed drawing. And the first step there, well, I mean, when we're loading models, we won't be doing this, but for now, each of these are 2-dimensional points. So unique points will have unique coordinates. We can see here we have a triangle with 3 vertices which are all different to each other, so no problem. What I'll do is I'll just add a labeling here to make it clearer, and then we can specify, all right, well, the indices for this are, 0, 1, 2. There it is. Those are the indices for the triangle. Now, I'll pass that along to the consume function, and I'll worry about that in a second. Just a note, here I'm using a NumPy array for the vertices because NumPy has a nice append function. It's quick. But with these indices, because I'm going to need to add offsets and things, it'll be a little easier just to do that element by element. So that's why I'm doing this with lists. Anyway, so now if I look here, I have, okay, vertex 0. This is a different vertex, so that'll be 1. This is a different vertex, so we'll call that 2. But now if you look here, this is the same as vertex 2. So this vertex has been duplicated. We don't want that. Now this is a new one, again, so we'll call that 3. And this is a copy of vertex 0 again. So the first step would be to remove the duplicates. Just paste this in. Remove the duplicates and label them if we want. And then we'll take the vertices, the indices that we used to draw each of these. So the first triangle was corner 0, 1, and 2. And then the next one, the 2 was doubled, the 0 was doubled. Anyway, so there we have it. So we'll pass that along to be consumed. Then finally, the star. Now this is pretty big, and as it turns out, a lot of this is duplicated. So let's grab all of this, and I'll paste in my version that I made previously. Believe me, it's not a lot of fun to find those duplicated vertices, but there we have it. And we can specify the indices as well and pass that along. When we come to loading models, we'll come up with a method which calculates all of this at the time, so that we I'm not going to load a 1,000-point model and check through by hand. That's too much. Anyway, so we pass this along to the Vertex Menagerie, and then we tell the Vertex Menagerie to finish itself up. So let's head over to the Vertex Menagerie and get that working. Okay, so I'm fine with this finalization chunk. We will be using those structures, those objects to finalize, but I'm just going to shift this around a little bit more so that it makes a little more sense. For one thing, we don't need an offset. I'm going to calculate that every time. I'm just going to change this to, not that, first indices. So it's a dictionary for a given mesh type. What is the first index? And how many indices are associated with drawing that mesh. And remember, this isn't the position of the first index. Do you know what I mean? After adding the offset, this is the location within the index buffer of where the first specification is for drawing. Does that make sense? Anyway, just refer to the previous earlier in this video. Now we don't just have a lump, we have a vertex lump, and we'll also have an index lump. And like I said, for the index lump, we'll just go with a regular array, and then we'll fix it up in the end. So, to consume, I'm going to shift this. I'm going to change the order here. So I'm going to actually grab the data right at the end. So I'll calculate the vertex count. Oh, and good idea to specify this. This is a NumPy array, and we'll have index data, which is a list of integers. Okay, cool. So we'll have the vertex count, but I'm also going to say, okay, what is the last vertex which we added to our lump? And the way we do that is we take the number of things currently stored in the vertex lump. So in other words, let's say I've specified like 5 vertices in my vertex buffer. Well, then when I go to add the next index, I need to know, well, this is referencing index number 1, for instance, but 5 vertices are already sitting there in my vertex lump, so add 5 to that. Anyway, so as well as this, I need the index count. That's how many indices are coming in for this object, and the last index, which is sitting there on my buffer, which is the length of the index lump. Okay, cool. So we can get rid of offset. That's fine. Don't need it. Let's go first indices, and that will be the last index. because we want to be clear of everything that we've drawn so far. And then index counts will be the index count. Okay, fair enough. So I'll just change this up. This will be vertex lump that we're appending to. And now for the indices. So we'll loop through. We'll say for index in the index data. The position of the last vertex will be the offset, and we'll add that to everything. Okay, cool. So I'm happy with that. We can close that down. The next stage is finalizing. So in order for this finalization to make more sense, this is going to be a pretty big function, but I'll just, first of all, just document the stages here, and then we'll repeat it. So we'll go this stage here. We are creating a staging buffer. And I should just double check all of this. So this won't be lump, this will be vertex lump. But that's fine. And then we'll write to it. Now we can get rid of that line. Okay, so we map to it, then we do the memory move, then unmap the memory. Okay, and now what we're doing is creating the vertex buffer. And I'll just change this name so it conforms to my naming convention, which I have been lax on, but anyway. Okay, I think that's fine. And then finally, destroy the staging buffer. Okay, cool. So now in order to create the index buffer, we will do the same thing. So grab everything here and repeat it. And that's why this is a big function. Well, don't forget the first thing we need to do is get that index buffer as a NumPy array. So I'll say get the index buffer from this constructor. And super important, the data type that we're using is unsigned integer 32. Okay, cool. So now we'll go through the same things. We do not need to recreate this input chunk. There it is. We do not need to rewrite the logical and physical device. We do need to rewrite the size. So that's the index buffer. Index lump. Why did I write buffer? Because I messed it up here. Okay, good spot. All right, so yeah, we do need to rewrite the usage and memory properties. So it might be tempting to say, wait a second, we set that up here. And yes, we did set that, but then we used that same input chunk to create the vertex buffer, at which point we reset this to something different. So let's set it. Okay, so then we write to it. Yep, so we map to the memory, but then we move the contents of index lump into that memory. Unmap it, that's fine. And then we create the index buffer, which means we need to change this to the usage being the index buffer. Okay, but everything else is fine. Yep, we'll copy to it. So then the source, the destination buffer will be the index buffer. And I keep repeating what I'm saying. Okay, and then we'll destroy the staging buffer. That's fine. Okay, so hopefully that should be okay. It's just an exercise in copy paste. Same with the destructor. So we'll just do all of this again, but of course, change the naming. It's the vertex buffer in this case, and the index buffer in the other case. Right, destroy the buffer, free the memory. There we are. We are good. So, okay, fair enough. Now let's go back to the engine and keep going with drawing. So here we're preparing the scene. I should probably just rename that. Okay. And what we also need to do is we need to bind the index buffer. So there we have it. We need to bind both the vertex and index buffers so that we can properly refer to each of them. Super important to specify the format that the indices are taking. I'll keep it at uint32 to have maximum possible range. Anyway, so record draw commands, that's fine. Render objects will need to change. So what have we got here? Yep, this is fine. We're binding the material. Okay. Now I'm just going to change this to first index. And I'm going to change this one to index count. Okay, now this draw command is going to change. It's going to be draw indexed. What do we have? The command buffer, and then this next one is the index count. Yep, instance count, that's fine. And then this will be first index. And then we have a vertex offset, which will just be 0. And then the first instance. Okay, so I'll just give that a second to lint itself. Okay, so let's go. Let's see if it works. It probably won't. You know how it is. We always miss something. Okay, what have we got? All right. Yeah, of course. What have I done here? Okay, so I'll just go back. This should not be... Yeah, okay. What have I got here? I've just got vertex lump. No. Should be calling the size function. That's getting the size property of it. Okay, give that another go. There we go. Okay, so there we have it. We are drawing everything, but we're now doing it in indexed mode. So that will improve the efficiency as models get larger, and it will also make it easier to do certain geometry operations, like later on, potentially building acceleration structures. Although I don't know, I might do Vulkan ray tracing in Python as well. I don't know, haven't decided yet. Anyway, so hope you had fun, and that'll be it for now. See you later. Bye.